Today we're going to talk about reflections. A reflection is a type of transformation. Remember, there's several different types of transformations, but a reflection is a specific type of transformation that creates a mirror image of an original shape or an original object. So the learning targets for this lesson, I can reflect shapes around a horizontal line, a vertical line, and the lines y equal x and y equal negative x. I can identify what a reflection is. So you should be able to do both of those things by the end of this lesson. Now there is a new vocab term. The new vocab term is called an isometry. An isometry is a transformation in which the original figure and its image are congruent. So basically I'm taking some type of shape, I'm moving it, I'm doing a transformation on it, but it is still going to maintain its original figure, its original shape. So the two shapes will be the exact same, it's just been moved in some type of direction. Maybe it was a translation, maybe it was a reflection, maybe it was a rotation, it was somehow moved, but it's still the exact same shape. When we take a look at this, we can identify a reflection here. The two shapes are the exact same, but all it did is construct a mirror image of itself. So you can basically think of this as being a piece of paper and this line right here called the line of transformation, or the line of reflection, excuse me, the line of reflection. What you can basically do is take this piece of paper and fold it up on that line of reflection. When you fold it, your two images, whatever the shapes are, whatever the images are, should end up folding up right on top of each other. So they should be the exact same when you fold this piece of paper on this line. So how did I perform this reflection? Just to go through it real quick in GeoGebra, I can select my polygon, make any type of polygon you would like, and then if you come up here and select this reflect about the line, when you do that, you can click on your polygon, click on your line, and you can make any line you want. So all you have to do is just use this line tool. So make any line you want. And when you click on that line, it performs the reflection for you. And you can see that these two shapes are the exact same. If I was to fold it on this piece of paper, they would land on top of each other. They're isometries. And then also you can see that one other reason I know that this is a reflection is because the distance. If I was to take each one of these vertices, the perpendicular distance to this line is congruent to the perpendicular distance from the reflection, from the vertices of the reflection to this line of reflection. So these distances are congruent. So now how do we go through and do this a little more by hand? So I went and made a line of reflection right here at x equal to 2. Remember, x equal to something is going to be a vertical line. Y equal to something is going to be a horizontal line. I went ahead and started making a triangle. I'll finish off my triangle though. So here's my triangle. And now my triangle, the vertices of my triangle are on specific coordinates. You can identify each one of the coordinates here. So how would I go through and perform this reflection by hand? Well, after I have my vertices, after I have my line of reflection, now what I would do is I would simply take a look at this perpendicular distance from the vertex to the line of reflection. Count that out, 1, 2. Well, if I want to make a reflection around that line, x equal to 2, all I have to do is figure out this perpendicular distance and then count it in the opposite direction. So 1, 2, 1, 2. And I can go ahead and plot my point. Same thing with this vertex as well. This vertex is 1, 2, 3, 4, 5 units away from the line of reflection. So go in the opposite direction. 1, 2, 3, 4, 5 units in the opposite direction. And then this one down here is 1, 2, 3, 4. 2, 3, 4. All right, I'm going to connect those dots. And I just performed my reflection about the line x equal to 2. Now we can basically construct or do any type of line of reflection, but we're going to stick with the more basic ones, the x equal to, y equal to, x equal to a value, the vertical lines, y equal to a value, the horizontal lines, and then also the lines y equal to x and y equal to negative x. So let's go ahead and put in a line y equal to, how about we do y equal to x? All right, there's my line y equal to x. Now I'm going to perform a reflection of this triangle right over here. So I'm going to take this triangle and reflect it around the line y equal to x. All right, so if from this line, the perpendicular distance to this point is just the hypotenuse basically of this square, of this triangle. So in the opposite direction, I would end up plotting a point right there, the opposite distance. Perpendicular, remember it has to be that perpendicular distance. This one here is 2 diagonal squares. So I need to make sure I go in the opposite direction, 2 diagonal squares. 1, 2, 1, 2. And then this point down here would be 1, 2, 3 diagonals. So 1, 2, 3 diagonals. Now there's a couple ways that you can plot your points to make sure you have that reflection. As you notice, I just counted the diagonal distance. But instead of counting the diagonal distance, there are other methods. So for example, like if I went to the right one and I went down one, if I went the opposite direction, that means I would go to the left one and I would go up one. So we can use the concepts of slope to help us figure out where these coordinates should be plotted. So this point right here would be to the right 1, 2, and down 1, 2. So from my line of symmetry, or my line of reflection, I could count to the left 1, 2, and up 1, 2 to get that point. So you can count your diagonal distances, you can count your squares. You just need to make sure that it is the reflection around the perpendicular distance to that line of reflection. All right, and then we can also put in our line y equal to negative x. So there's our line y equal to negative x. And I'm actually going to use this shape down here. Let's talk about the reflection of this shape. This one's kind of interesting. If I was to reflect this shape around the line y equal to negative x, when I reflect this point right here, this point is 1 diagonal distance. So if I go the opposite direction 1 diagonal distance, I end up right on top of this point. So reflecting that point lands itself on top of B. Well, now if I reflect the point B, it ends up right on top of C. And if I reflect the point D is on the line of reflection, so it does not reflect. So this shape, when I reflect it, ends up being the exact same shape. Now remember, when you do your image and your pre-image is labeled with the letters. But your image, after you reflect it, your image should be labeled with prime notation. So after I reflect this, I should have some type of annotation showing me that this would be D prime. When I reflect it down here, this would become C prime. When I reflect it down here, this would become B prime. So make sure you use that prime notation whenever you're doing your reflections, whenever you're doing your isometries, whenever you're showing your translations. All right. So that should give you a fairly basic understanding of how do I do those reflections around any type of line, any type of horizontal, vertical, or those 2 diagonal lines. And the same thing would happen if you had a horizontal line. So if I had a horizontal line and a shape of some sort, then it's just a matter of going the opposite distance. So if this is 1, I need to go 1 in the other direction and plot my point. If this was 2, go 2 in the other direction, plot your point, and so on, and so on. And that's how you're going to come up with your reflection. Now this line of reflection can also be referred to as a line of symmetry. And that's because what it's doing is it's creating symmetry on both sides. After you reflect it, it's creating symmetry on both sides. In other words, both sides look identical. So it's a mirror image. Well, we can take shapes, and we can determine how many lines of symmetry that certain shapes have. So if I go back to GeoGebra real quick, take a look at this triangle. With this triangle, what I'm basically saying is take a line and slice it. Slice it however you can. And I want to know how many lines can I slice this image with so that I end up with the exact same shape. So right now I have this one line that cuts through it. And that one line cuts it into two identical pieces. So are there any more lines that I could cut through this shape and come up with two identical pieces? That's a line of symmetry. So it's easier to identify lines of symmetry when you have regular polygons. So let me get a polygon here real quick. All right. So take a look at this this square here. How many lines could I cut through this to make two identical pieces? Well, I can slice it this way, and I have two identical pieces, so there's one line of symmetry. I can slice it this way, and I've just created two identical pieces. I can actually slice through it this way also and create two identical pieces. I can even slice it this way and create two identical pieces. So to me, it looks like there would be 1, 2, 3, 4 lines of symmetry for this shape. Now, the only reason I'm introducing this real quick is because you're going to be shown some shapes, and you're going to have to identify the symmetry of those shapes. And the symmetry of those shapes is going to help us later on when we are calculating these interior angles. So that's why I'm introducing these lines of symmetry now. Okay, that concludes our discussion on reflections. Again, hopefully at this point you should be able to perform a reflection. You should be able to reflect around horizontal vertical lines, y equal to x, y equal to negative x, and you should be able to identify when there is a reflection and when there isn't a reflection.